Finished with that first section. All right, let's talk about something a little bit different, but it kind of comes back to something that appeared in that very first section worth of notes. Remember those cost and revenue functions? Well, the next section is all about what we mean when we talk about functions. So there are definitions there about a relation, which is just kind of like pairs of matched x and y values you can think of. A function is a specific type of relation. So like all functions are relations, but not all relations are functions. So you can read the definitions there, and the special thing where each thing, each x, can only point to, one y, that kind of thing. I like drawing a picture sort of to illustrate the point of what's going on here. So imagine all of my x values live inside this circle, all of my y values live inside this guy. My function f is like a map. It's a road map, essentially. It tells me from a given x, how do I get to the corresponding y? So you can sort of think f is like a series, this function f of x, as so that's not f times x when we write f parentheses x. That's f of x is how it reads. So the idea is if we start from some value x right over here in the big domain circle, so this is what we would call the domain of the function. Over here, you may have heard the word codomain in a math class before. Don't worry about that. Look. The y values, where the arrows sort of, point, that's what we call the range of the function. So, and we may have multiple, x values over here, and we may have some corresponding, y values. So the idea for it to be a function is that no dot over here can have two separate arrows starting from it. So I couldn't draw another arrow from this x out to another dot over in the y circle. Hopefully that makes sense. Although you can have multiple x's all point to the same y. So there's nothing necessarily wrong with having another arrow that goes over to this fellow. We could have 3 or 4 of them all point to the one. But I'll draw some more. So the idea is this function f, or f of x, is basically kind of like, you can think of it visually as like the collection of the arrows telling us how to get from x values here to y values over in that range set. Now, we don't really need to deal with functions in that abstract a sense that often in a Math 210. So if that feels a little out there for you, it's okay. It's just there to try to give you sort of some visualization as to what's going on. The way we will most often deal with functions in this course is via a formula that's supplied to us. So you've got this function that's presented in this first example here. We have 3x cubed plus 2x squared. I'm keep looking because I want to make sure I don't get it wrong. So we have 3x cubed plus 2x squared minus 8x plus 5. All right. So now the idea is, how do we evaluate this function for a given x? So you'll notice there's some blurbs underneath there. So if we wanted the value of the function when x is equal to 3, well, basically the idea is everywhere we see an x in this formula, that value 3 is going to go in its place. So we have 3 times 3 cubed plus 2 times 3 squared minus 8 times 3 plus 5. And then from here, it's an exercise in arithmetic, right? You work out the multiplications and then add and subtract accordingly. When you do that, you should end up getting an overall function value of 80. So, the same thing happens with this next guy, f of negative 2. So everywhere we see an x, negative 2 goes into its place. If you're putting this into your calculator, I can't stress this enough. Get in the habit when you're dealing with negative numbers of enclosing that thing in parentheses before you raise it to a power. We'll talk about why just a second here. But yeah, I want to go ahead and plug in the rest of the spots where the negative 2 should go in. Now, if you don't use these parentheses when you put it in your calculator, the way it does its operations will mess things up. So, negative 2 times negative 2, or negative 2 squared, should give you a positive 4, right? Because negative times negative gives us positive. That's something you've seen in the past. I'm certain at this point. But if you don't type those parentheses, the way the calculator reads the operations, if you think back to the old please excuse my dear Aunt Sally routine for the order of operations, it does that exponent first. So it says, 2 squared would be 4, then it sees that negative and it's thinking of it as multiplying by -1. So then it does, oh, -1 times 4 is -4. That is precisely what you do not want out of that guy. And if you work out the arithmetic without those parentheses, when you do the -2 squared, you will not get the answer I would like to see, which is in fact 5. All right, so that's 2 of the 3 bits of this first example down. The last bit, it feels a little weird. So instead of a number, they just kind of put another letter in there. It's kind of like they're just switching the variable. So you have f of c. So everywhere we see an x, what should go into its place? Well, c. So we have 3c cubed plus 2c squared minus 8c plus 5. And there's not really anything else I would be expecting you to do with that. It's basically just kind of, a part of me wonders if it's there just to try to get you into thinking, it's possible for you there to be a variable other than x. I've had a lot of students through the years who, they'll kind of get tripped up on that. But it's not too, as you say, it's not too big a transition point here. All right, so that's playing around with functions kind of at the base level, getting used to dealing with formulas. I'm giving you the picture. So if you flip through the next page of the section 1.2 notes, which is unfortunately in the same PDF file as the section 1.1 notes, hopefully that's not too confusing, but it helps to compactify the stuff. All right, so if you turn to the next page, there's a bunch of stuff about putting functions together, sort of new functions from old. So you're given a couple of different formulas for functions. F of x equals, and then g of x equals, and then you're asked to evaluate some formulas for these guys. All right. So making sure I get this right, x to the 5th, and then g of x is 7x. Okay, and go ahead and get rid of my formula stuff here to make space. Awesome. All right, so now we're going to combine these guys. So kind of rattling down the list, we have f plus g of x. My marker is starting to die. I apologize for that. We'll bring in a new one soon. He's served us well, right? So as it turns out, this really is exactly what you'd expect. You don't need to do anything fancy. It almost looks like you're kind of distributing the of x. That's not what's happening. But it does just look like f of x plus g of x. So then you can just take the formulas and kind of add them together. X to the 5th plus 7x. There's not much you could do with it. I mean, you might try to do some fancy algebra factoring, but that's beyond the scope of what I would expect. Just don't try to combine those. It doesn't turn into 7x to the 6th or anything like that. By the same token, the next guy up asks, what about f minus g of x? And you're probably used to subtraction and addition behaving more or less the same way. So yeah, believe it or not, it's just going to be x to the 5th minus 7x for that guy. So the next one up, you see that little dot. I don't know if it's showing up on the board clearly, but you can see it on the notes file. That dot indicates multiplication. We usually don't use x for multiplication that often because it pops up as a variable all the time. So yeah, same deal here. We take f of x, we take g of x, we multiply them together. Now this time around, we can actually do a little bit with this. If you remember properties of exponents, you can poke around online if you need to practice with that. Remember, if an exponent's not written, it's kind of implicitly assumed to be a 1. So we have x to the 5th times 7 times x to the 1st. Our properties of exponents say we can add those exponents together. So we get, as it turns out, that 7x to the 6th that I mentioned earlier. It wasn't the plus, it's the product. All right. So yeah, if you need to look at properties of exponents, it's okay. You might also think about this as 5 copies of x, and then you've got one more tacked onto it, so that's a total of 6 copies of x, thus x to the 6th. I don't usually write the slash for division. I write it like a fraction. I mean, they mean the same thing. But just like we saw before, it's f of x over g of x, or f of x divided by g of x. So we have x to the 5th up top, 7x down below, and now we can cancel away one of the copies of x, right? Go slash, and we only have 4 copies of x left in the numerator. So we have x to the 4th over 7 is our formula for the quotient function, if you will. You don't normally hear sum, difference, product, and quotient functions, but just in case it comes up, that's what's happening here. All right, so far, they pretty much all behave like you'd expect, right? Plus is addition, minus is subtraction, division. So you get the idea. That next guy is a little bit different in how he behaves, and I think that's a good chance to pause. Hopefully this introductory stuff hasn't been too challenging as far as functions go. We'll take a look at what that little bubble between the f and the g means next time.